Okay, last time we talked a lot about the properties and states of matter. Today we're going to talk about how matter is classified and the different categories that we put it into. Okay, still no math, still information. So again, every time that I highlight or write something down, you should highlight or write it down, or underline it if you don't have a highlighter. Okay, the first category of matter is what are referred to as pure substances. And when we define a pure substance, we're going to say that every sample has the same composition and the same properties. Okay, so it's uniform throughout. For example, this is solid sodium right here. Okay, this is chlorine gas. So these would all be pure. When we combine these two together, we get this lovely, what we call exothermic reaction, where energy is generated, and we get what we know as salt, or table salt, or sodium chloride. But all three of these things, sodium, chlorine, and sodium chloride, all have uniform properties. And pure substances are typically going to fall into one of two categories. They're either going to be an element, okay, so iron, gold, sodium, chlorine, again, that whole, anything on the periodic table that we're going to talk about a little bit later in this unit, or a compound, okay, so and we learned that a compound is when two or more types of atoms are chemically bonded together. So for example, sodium chloride is something that we'll talk a lot about, plain old table salt. This is the formula for sugar. Okay, C6H12O6, and then this is the formula for water. Okay, so anything where you have a chemical compound is going to also be a pure substance, so either an element or a compound for that one. Okay, so for example, if we look at these and we say which ones are pure substances, we're looking for things that are exactly the same. So the only two that are going to fall in that category are going to be B and C. Okay, here this is most likely an element, all the same color, two atoms bonded together, and we'll talk about what elements are found that way in nature. Here you have a compound, one of each element, but again they're all the same. A is not going to be a pure substance because you have different things that are only physically combined, which we're going to talk about here in just a minute as a mixture. Okay, which is not going to be a pure substance, which leads us right into this slide. So a mixture we are going to define as a blend of two or more types of matter. Okay, and when we mean blend, we mean that each component keeps its own identity and properties. So if you could separate them back out again, they would be exactly the same. So it's a blend that each component keeps its own identity and properties. And again, it's this whole idea that the components are only physically mixed together, not chemically. Big difference here, and you're going to hear me use those two terms throughout this unit, physically combined as opposed to chemically combined, which also means they can be separated using physical means. Now sometimes those physical means are very simple and you can reach in and pull them apart. Other time we're going to have to use more scientific technique, so to speak, because things are just smaller and you can't just reach in. Now what's called a homogeneous mixture, okay, a synonym for that or another word for it is what's called a solution. Now a homogeneous mixture from the outside is uniform in composition. You cannot see the parts and pieces, so the parts are not visible. For example, vinegar. Vinegar is a solution of what's called acetic acid and water. Well, you can't see the acetic acid particles floating around in the vinegar. You can't see the water particles, but they are just physically combined. Clear air is the same thing. Clear air is a combination of nitrogen gas, oxygen gas, hydrogen gas, water vapor, carbon dioxide, all kinds of things. We can't see the parts and pieces, but there are separate places. And same with salt water. Salt water, you have the sodium and the chloride ions, which we'll talk about later, mixed in with the water particles, but all the pieces maintain their own identity. And then ultimately, you know, we've all been through this, when you get out of the ocean, the water evaporates and you're left with the salt. Chemical reaction didn't occur on your skin, it's just the water evaporated and it was separated out. Okay, so homogeneous mixture is a solution, uniform in composition with no visible parts. Brass is another example. It's a little bit tougher to conceptualize, but brass is a mixture of two different metals that are mixed together at a very high temperature. When they cool down, you can't see the different metals that are there. It appears uniform. Okay, now heterogeneous then is going to be the opposite. Okay, hetero usually, the prefix hetero usually means different. These are things that are not uniform in composition that do have visible parts that you can see. So for example, soil. You can, a lot of times if you look at soil, you can see different smaller pieces of rock or organic matter and stuff mixed in. Concrete, okay, which is right here, you can see the different rocks that are in there and that have settled in to form that concrete. Blood. Now you may go, okay, wait a minute, if I look at blood, I can't see the visible parts and pieces just on the naked eye, because here is a microscopic version where you've got the white blood cells and the red blood cells. However, if you've ever donated blood, you'll notice that a lot of times they keep it on a mixer, and if you let blood settle for any length of time, it will separate by density fairly quickly. So the blood is an example of a heterogeneous mixture that you'll hear me ask you a lot about. Chocolate chip cookies, obviously, well, they're M&M cookies, but you can see the parts and pieces. Sand and water, iced tea with ice, you can see the ice separate from the parts and pieces. Okay, so those are just examples of heterogeneous mixtures that are not uniform in composition and that do have visible parts and pieces. Okay, so again, here's just another example of that. Here's your granite, your heterogeneous mixture, human blood, again the heterogeneous mixture, and then this is a solution, and we'll deal a lot with solutions second semester, of what's called copper 2 sulfate, which it's kind of, from a chemistry standpoint, not much different than salt water, but copper 2, when it's in solution, has this pretty blue color, so it makes it a little bit more interesting to look at than just clear salt water. Okay, this is a little concept map. We'll probably draw one of these in class as well. I like concept maps because they show the connection between things. So matter is the big broad topic, okay, and when we do a concept map, the top thing is going to include everything below it. Matter is separated into two groups. You've got your pure substances, which cannot be physically separated. You've got your mixtures, which can be physically separated. Under pure substances, you have two types. You have elements, anything on the periodic table. You also have compounds, okay, water, table salt, we've talked about as NaCl. Ammonia is NH3. We'll deal with that a lot this year. Those are your pure substances, elements and compounds. Your mixtures, as we talked about, you've got homogeneous mixtures or solution, and you've got heterogeneous mixtures, which do have visible parts. Okay, so again, just another way of organizing that material so that we can keep that straight. Now, if we've talked about mixtures and physical separation, we need to talk about some techniques that we use in the chemistry lab that aren't as simple as just pulling things together. Okay, if I have some mixtures, you can just reach in and separate them. Sometimes that's not always the case. The first one is called filtration, and filtration, the solid part of a mixture is trapped by filter paper, and that's this stuff right here. The liquid part runs through. Now, if you've ever cooked pasta or anything where you've used a strainer, you've done this, you just didn't call it filtration, okay? And instead of filter paper, you had a colander or a strainer there. Okay, then vaporization is where the liquid portion is evaporated off to leave the solid. Now, if you remember, we talked about changes of state last section. Vaporization is going from a liquid to a gas, and there's two types. You have evaporation, which typically does not have bubbles. And then you also have boiling, which does have bubbles. Okay, so if we have not covered that in class, and vaporization right here is where the liquid portion is evaporated to leave the solid behind. You can speed up vaporization by heating it and causing it to boil. I just wanted to make sure that we point out the difference between those terms, in case we hadn't done it. Vaporization is the big umbrella of liquid to gas. No bubbles, we typically refer to that as evaporation. If you do have bubbles, we refer to that as boiling. So I guess we should say for our definition here is evaporated or boiled off, just depending on if you use heat or not. Okay, paper chromatography. I think the definition is pretty obvious, but it's used to separate mixtures because different parts move quicker on paper than others. Here you have a black line that was drawn with a marker. And on filter paper, there's some water down here, and if you get it wet, you'll see that the ink starts to run up the paper. And essentially in a time lapse, you start to see that the blue will travel further, the red in the middle, and the yellow. So this is just separating out the black ink. And the good part about, I realize all these techniques right now, you're like, okay, great, these definitions don't mean much to me. We're going to get hands-on experience with these in lab over the next couple days, and that should help. Okay, decanting is it's similar to filtration, but this is when the liquid is simply poured off after the solid has settled to the bottom. So we're not actually going to take the time to run it through the filter paper, and a lot of times we decant first, okay, and then we filter. Hint, hint, that will speed up your life a little bit, but we decant first and then we run it through the filter paper. But that's just another kind of a step. And then a centrifuge is a machine that spins a sample very quickly so that the components when different densities will separate. If you've ever been on those machines or those rides at the fair that spin really fast and throw you into the wall, same mechanism, except we're trying to separate mixtures that are in solution. And I'll show you an example of a centrifuge in class as well. Okay, that concludes our video for, oops,